Hello pre-calculus students, and welcome to a video on Cramer's rule. And Cramer's rule is just a process that we use to solve systems of equations. Now you all know how to solve a 2x2 system of equations. Just to show you an example that's on this page. Here's a 2x2. You can use substitution method, elimination method. You can even solve it by graphing. But I'm going to show you how to use a different method called Cramer's rule. And then the nice thing about Cramer's rule is once you understand it, it extends to 3x3 equations. So there could be an x, y, and a z. There could even be 4 equations with 4 unknowns, and there's really no limit. It's just a lot of work, but it's very systematic. Okay, so the first thing that we need to talk about is what the main tool of Cramer's rule is called a determinant. So we need to talk about what is a determinant. And every determinant higher than a 2x2 depends on being able to quickly solve a 2x2 determinant. So here's all it is. So it looks like it's an absolute value, kind of. It looks like an absolute value of, let's say, 4 entries. It's always going to be a square. So A, B, C, D, something like that. Okay, there's nothing like the absolute value. It just looks like that. And you always start here. Start with the top left, as if you're reading a book. All right, and what we're going to do is we're going to subtract this product minus this product. That's all. That's all there is to it. So your determinant will equal the value when we're done, when we look at an example, and it's going to be the product of A times D minus the product of B times C. That's it. Okay, let's look at an example. Let's say that we had the 2x2 determinant. That's 4, -3, -1, 2. Okay, so we're going to multiply 4 times 2. So this just equals 4 times 2 minus -3 times -1. -3, and I'm going to use the parentheses for those negatives so that we don't get confused. All right, so this would be 8 minus 4. Sorry, 3 times 1 is 3, so 8 minus 3, which is 5. So that's it. The value of this determinant is really just 5. Okay? So how is this going to help us? Well, here's the process that we're going to use for Cramer's rule. We're going to get a system of 2 equations, and we're going to find 3 different determinants. Okay? Here's going to be the x. This is going to be called the d, just d, for determinant. Then we're going to find this one right here. We're going to cross out the first one and we're going to replace it with the s and t. So that's going to be our dx. We'll replace the solutions with the x's, the x column. That's going to be our dx. And then, no surprise, our dy will be to cross out those and replace them to make a determinant with these are all just coefficients for dy. So in other words, if you have your equations labeled a, b, and s and t like this, then your d determinant will just be the determinant a, b, c, d. Your dx would be replacing this, would be s, t, d, b, d. So s, t for the first column replaces the a and c, and then a b and a d. And then for the y's, you're going to have ac for the first column, and then st replacing the middle one. So st over here. And that's called your dy. Okay, we could write them out what they are, but we've already got that up here. It's following the same rule. All right, let's actually do this to a system of equations. Now, you can check this because you already know how to solve the system of equations, but I'm going to find the 3 determinants that we just talked about. So d would be evaluating the determinant that just keeps the coefficients of x and y. So it would be 3, -2, 6, 1, which would be 3 times 1, that's 3, minus -2 times 6, so minus -12, and that would give us 15. So d is 15. Okay, next one. Dx would give us the determinant where we replace these coefficients with the 4 and the 13. So we'd have 4 and 13 for our first column, and then the -2 and the 1 for our second column. And then let's just apply the rule for determinants. So we have 4 times 1, which is 4, minus -26, which is 30. Why don't you guys try this one? Same thing. I'm just going to work it out and you will compare. Okay, so there it is. We replaced the 3 and the 6 with the 4 and the 13. Sorry, this is the y, this is dy. I kept the 3 and the 6, and I replaced the negative 2, 1 with the 4 and the 13, and then I multiplied that way, subtracted, and I got 15. All right, so what's Cramer's rule? Here's the rule right here. Once you understand all the pieces, this is the rule. So to find the x-coordinate of the solution, it's dx over d. To find the y-coordinate of the solution, it's dy over d. And this only works, of course, you can't have a denominator of 0. We will talk about what that means if you do have a denominator of 0 on Friday. But for now, you can only solve these if they don't have a denominator of 0. So to finish this example, the x-coordinate, so we found so far that d is equal to 15, that dx, or d sub x is equal to 30, and that d sub y is equal to 15. So if I want to find the x-coordinate, it's just going to be dx over d, which is 30 over 15. 30 over 15, which is 2. So x is 2. If I want to find y, I just take dy over d. So I get 15 over 15, which is 1, so y is 1. So these two lines that were originally given here, and just wrote down 3 times, intersect at 2, 1. That's the solution. In general, I don't really care if you leave your solution as x equals y equals, or you write it as an ordered pair. When we get to 3 dimensions, we're going to have ordered triples, which you probably haven't seen before. And that's it. Okay, hope you found this helpful.